Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at completing the square. So completing the square is when you have a quadratic equation in this form and you want to write it in this form. So why do we want to do that? Well, this is going to help us in graphing parabolas. You see, if it's in this form, we don't really know how to graph it. But we do know how to graph it if it's in this form called turning point form. So we need a technique to start off with an equation like this and end up with something like that. So how are we going to go about this? Well, this is based on the fact that if you have a perfect square like x minus 3 squared, if you use FOIL and expand that, you'll get this. The idea here is that this coefficient of x is double what's in the brackets. So negative 3 times 2 is negative 6. This number here is the square of the number in brackets. Negative 3 squared gives us positive 9. So this is the basic idea. If you have something like x squared plus bx plus c, you halve this, it goes in the brackets, and then you square it, and then outside the brackets will just be this number minus half of this squared. Now that sounds a bit complicated, but hopefully it'll become a lot easier after we go through some examples. So let's say we have x squared plus 4x plus 9. If I wanted to graph the parabola y equals x squared plus 4x plus 9, we don't know how to do it. What we're going to do is write that so it looks like this, and then in subsequent lessons we will be able to graph it. So this will be x plus 2 squared. Why did I choose 2 here of all numbers? Because it's half of 4. Half of 4 is 2, so a 2 goes in there. So what goes outside the brackets? Well, it would be 9 minus 2 squared. 9 minus 4, which is 5, positive 5. So now it's in turning point form. We would be able to graph this a lot easier. All right, let's try this one here. So I want to put it in completing the square form, in turning point form. So what goes in the brackets is going to be negative 6. Why negative 6? Because it's half of negative 12. So what goes outside the brackets here? It's 30 minus negative 6 squared. So negative 6 squared is positive 36. So what goes out here will be 30 minus 36. And of course 30 minus 36 just gives us negative 6. So sometimes you'll get a positive outside the brackets, sometimes a negative. All right, let's look at something like this. So this one's a bit different because it has a 2 in front of the x squared. So what we're going to do is first factorize it, because these three terms have a common factor of 2. So if I take out 2, what do I times by 2 to get 2x squared? Well, that's just x squared. What do I times by 2 to get 12x? Well, that's 6x. What do I times by 2 to get to 10? Well, that's just 5. So I've got the 2 out the front now. I'm going to complete the square on this expression here. So I'm going to leave the 2 alone for now. So I want to write this in the form x plus h squared plus k. So inside the brackets, it will be x plus 3 squared. Why did I choose 3 of all numbers? Because it's half of 6. So what will go outside the brackets? It will be 5, the positive 5 I had before, minus 3 squared. 5 minus 9. And of course, 5 minus 9 just gives us negative 4. Okay, so now I can expand the brackets. I get 2 times x plus 3 squared, but I also need to times the 2 by the negative 4. And 2 times negative 4 is negative 8. So now all of these are in turning point form, and I'd be able to graph them easily. All right, let's now look at solving quadratic equations using completing the square. So we're going to look at how to solve these equations. So how's this going to help us with our graphing? Well, solving these equations actually gives us the x-intercepts. See, what we're having here, we'll have some Cartesian plane, and we want to draw a parabola, and sometimes it will hit the x-axis. So sometimes it will have 2 x-intercepts, sometimes it will have just one x-intercept. Sometimes it actually has no x-intercepts. But this method I'm about to show you will help us determine the x-intercepts if there are them. It'll calculate this value and this value because this is the x-axis. Where it hits the x-axis is where y equals 0. So if you have an equation like y equals x squared plus 6x plus 5, then to find where it hits the x-axis, you would just change y to 0 and you get this equation here. So now we're solving quadratic equations. That will help us with x-intercepts. So how do we solve the equations? Well, we're going to follow these steps. Complete the square, factorize using difference of two squares, then use the null factor law. So let's look at it on this one here. So firstly, I'm going to complete the square. So that means I'm going to write it as x plus 3 squared. Why did I choose 3? Because it's half of 6. So then outside the brackets, we have 5 minus 3 squared, which is negative 4. 5 minus 9 is negative 4. So now we've put it in completing the square form. So secondly, we're going to factorize using difference of two squares. So remember, for difference of two squares, that's when you have a perfect square minus a perfect square. So we square root the first. Square root of x plus 3 squared is just x plus 3. So we'll put that in both brackets. And then we square root 4, which is 2. One bracket gets a plus between them, one gets a minus. So we have x plus 3 plus 2, x plus 5. And then the second one, x plus 3 minus 2, is just x plus 1. Because, of course, 3 minus 2 is just 1. So now we're going to use the null factor law. The null factor law says if you have something times something equals 0, either the first bracket equals 0, the first thing equals 0, or the second thing equals 0. So we actually have two solutions here. If x plus 5 equals 0, x is just negative 5. If x plus 1 equals 0, x is negative 1. So if I were to graph y equals x squared plus 6x plus 5, it would have x-intercepts at negative 5 and negative 1. So what about this one here? X squared minus 4x minus 5. We're going to start by completing the square. So it'll be x minus 2 squared. Y negative 2 because it's half of negative 4. So what goes outside? We take our value of c and we minus 2 squared. So negative 5 minus 4 actually gives us negative 9. So we end up with x minus 2 squared, subtract 9, gives 0. All right, first step done, completing the square form. Now we're going to factorize using difference of two squares. So difference of two squares, we square root the first thing, that's the x minus 2 squared, we square root it. We square root 9, one gets a plus, one gets a minus. So negative 2 plus 3 is positive 1. All I did was go negative 2 plus 3 gives us 1. Negative 2 minus 3 is negative 5. So now we have two things multiplied to give 0. So either the first thing equals 0, if x plus 1 equals 0, x would just be negative 1. In other words, negative 1 is the number that makes the first bracket equal 0, and the number that makes this bracket equal 0 is positive 5. So they are the two solutions. If you were to graph y equals x squared minus 4x minus 5, it would have two x-intercepts at negative 1 and 5. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.